Hey everyone, my name is Nico Jovanovic. I play hockey and I'm a junior at Notre Dame studying chemical engineering, and I'll be taking you guys through the manufacturing and quality areas of our launch. But before I get into that, I first want to introduce everyone to Mr. Antibody. He's a hardworking and loyal monoclonal antibody whose job is to target amyloid buildup and destroy it. Right now, I'm going to take you guys through Mr. Antibody's production journey, beginning before he's been born. The first thing we need to produce Mr. Antibody are host cells. These host cells are embedded with genetic code that make them produce Mr. Antibody. The cells that are most successful in producing Mr. Antibody are then used as the seeds from which the cell colonies are grown through large-scale fermentation within the bioreactors, which are about the size of those in the picture that you can see to the right. Importantly, they are single-use reactors and they're not reused. The last step we see is a basic purification step where a centrifuge and a filter will separate Mr. Antibody from the extra food and leftover materials from the reactor. In real life, Mr. Antibody will be produced in Ireland at the Lilly Kinsale site. This site produces Mr. Antibody and his twin brothers at a rate of 120 kilos per month, and this rate accounts for the production's 70% yield. So everyone knows, upstream processing is where the cells are grown and produce Mr. Antibody, whereas downstream processing is all about removing the things we don't want in our formulated product. If you look closely at the unit operations flow diagram, which I know looks intimidating, you can see Mr. Antibody hanging out after he's been born in the reactors, waiting to be cleaned up in the purification steps downstream. Lilly's site in France is a parenteral site, and all that means is that it manufactures products that are meant to be injected rather than swallowed. The production rate at this site is about 1 million vials per month, which I converted to 350 kilos by using the volume in each vial and each vial's concentration, and this accounts for the yield at the site. To meet the supply and demand of Mr. Antibody, these are some of the important factors that can fundamentally limit his production. The first is that the Kinsale site limits the overall production rate because it has less than half the production capacity of France. The campaign-based production in both sites also presents potential supply issues relative to the demand and Lilly's ability to store Mr. Antibody. This refrigerated storage infrastructure, which is otherwise known as his paid time off, is a critical part of the production planning and can limit it because of the campaign practices. That seems like a pretty cool vacation if you ask me. So now next we're going to look at a couple scenarios where Mr. Antibody will face different kinds of problems in production. So in scenario 1, the launch was successful and the demand is in line with what we predicted, but unfortunately we're having problems with our bioreactors. A main problem this kind of production faces is its reliance on cells to produce Mr. Antibody. Non-ideal cell lines could dominate the colonies that are growing inside the reactors, which could result in lower yields because not all the cells are producing him effectively. Cells are also really sensitive to their environment, so if there are contaminants, nutrition problems, or mixing problems like not getting enough oxygen through the reactor is one of them, the yield would be impacted. All these possibilities have corrective measures. So, for example, we can verify the optimal cell selection with lab testing to determine if the cell lines need to be re-engineered, and we can also use sensors to monitor levels of all the relevant conditions for fermentation. Also, if you remember when I was introducing the bioreactors, I said they were single use, and that addresses a lot of these issues as well. In scenario 2, business is booming, and we need to scale up the production of Mr. Antibody to meet a greater demand. Since the Kinsale site limits the production rate, we'll need to scale up all their processes. And to prepare for this, we need to ensure that there's enough supply of raw production materials available to meet these demands. Also, all the in-house unit operations for purifying Mr. Antibody need to be scaled, which also means that we need to make sure there's space to expand operations at the site. There will also be a campaign plan already in place based on the original demand forecast, but now we need to increase the frequency of those campaigns to match the new demand. So with that being said, there are other factors that go into campaign scheduling, like ethical obligations, which are from regulatory authorities. The main reason this comes up is because the obligations other drugs might have in the marketplace, which makes their supply critical. In this case, it would be beneficial to relocate production of those ethically obligated drugs to other sites whose drug lineups don't have any new-to-market drugs, so that we can ensure the Kisunla campaigns are minimally impacted by these kind of issues. And lastly, one of the other ways we can manage these issues is by preemptively increasing our storage capacity and stockpiling product, which is lower in cost relative to switching campaigns at a production facility. The point of our quality management system is for Mr. Antibody to retain the attributes that ensure he destroys amyloid buildup. And we do this by continuously monitoring his 10 critical quality attributes. We do this in production, at the end of the production, and also when he's enjoying his paid time off in storage before being called into work. If our data indicates that Mr. Antibody failed to meet a critical attribute, the first thing we need to do is identify which of his attributes aren't standard. Then we need to narrow down the potential sources of error by investigating production areas that relate to this attribute. So an example of this would be if his purity attribute was too low, we would immediately narrow down our search to filtration or whatever other purification steps could be the source of the problem. After that, we use targeted questioning. The data streams from our sensors in the different levels of production and repeatedly ask why until we get to our root cause. After that, we have to assess its impact in our production line and correct the problem. On the other hand, if Mr. Antibody checks out and has all his critical quality attributes, he's ready to go and he can get to work destroying amyloid. If you guys want to dive deeper into Mr. Antibody's manufacturing journey, you guys will have to catch me at the National Championship game on Monday. So for now, I'm going to pass the football over to Emma so she can take over.